Hey there, everybody. This is a video of me going over every problem on this prerequisite packet. You need to know every single one of these problems. This is something that I will not be teaching you again. You should just know these from Algebra 2 or Math 3. They will be required throughout the course of this pre-calculus lessons. So I will go through each one of these, and then you will have a quiz on this. Try not to sit and watch all of this in one setting or put me at double speed. I know you want to. Just pause after each page, maybe come back to it and rewatch it again. So the first part is about writing equations in slope-intercept form. If you remember slope-intercept form, y equals mx plus b. That's how I want it to be finished. So if they give you a slope and it passes through a point, the way that I do it is I actually use the point slope form, which says y minus y1 equals m times x minus x1. Your m is the slope, your x1 and your y1 are the 6 and the 9. And then you leave this first y and this first x open. So you would write y minus, this would be your y1, 9. Your m would be the slope. You would leave this x, and your x1 would be the 6. Again, this is called the point slope form. Now that it's written like that, you're going to write it in y equals mx plus b form. So y minus 9 equals 4x minus 24. And then add the 9. Y equals 4x minus 15 is your answer. Passing through the point -8, -8, -5, 3, -10. So first we need to find a slope. So that is, if you remember, y2 minus y1, which is plus 5, and then 3 minus -8. So that would be -5 over 11. And then I put it into the point slope form. Again, you may have put it in here and found your b. That's fine also, but I just like point slope form. I'm going to pick this point. So y minus y1 equals m, which is -5/11, times an x minus your x1, which would be 3. And then you want to simplify it, 15/11, and then you're going to minus the 10 over. You're going to simplify it to this form. Minus 10 would be, -95 over 11, I believe. Okay, equations that are parallel and perpendicular. Remember, if they're parallel, they have the same slope. I solve for y, -3x equals minus 4x minus 24, and divide by -3. Would give you y equals positive 4/3 x plus 8. That is our slope, so that's the slope we're going to use for a parallel line. 4/3. And then we're going to do the same thing we do up here. We're going to write, using this point, y minus y1, so plus 6, equals m times x minus x1, which is also -6. And then put it into the correct form up here, and I'm going to kind of quickly solve that for you. 4/3 x plus 2. Now, if it's perpendicular, a perpendicular slope would be the opposite reciprocal. So if this slope right here is -2, I want the opposite, which is positive, and I want to reciprocate 2, which is 1/2. So I'm going to use 1/2, and I'm going to plug it into my point slope form. So y minus y1, which is 2, equals m times x minus x1. And again, you should get y equals 1/2 x. All right, finding the x and y intercepts. Those are actually very easy. You just have to plug a 0 in for x, and that'll be your y-intercept. So if I made this 0, you would have -3y plus 8 equals 0. And solving, you would get y equals 8/3. So when x is 0, Y is 8/3. That is called a y-intercept. An x-intercept, you plug a 0 in for y. It's like the flip-flop. So if I plug 0 in for y, I would have 2x plus 8 equals 0. 2x equals -8, x is -4. So when I made y 0, I got -4. This is your x-intercept. Same thing here, just this is fancy notation for function. This is really a y. So this is really y equals 4x minus 10. You're going to do the same thing. Plug a 0 in for x, you get y equals -10. So when x is 0, y is -10. That's your y-intercept. Plug a 0 in for y, you get 0 equals 4x minus 10. So x is 5/2. So then you would write x is 5/2, y is 0. That is your x-intercept. Graphing a line, you really need to know how to graph a line without using your graphing calculator, even though we will use our graphing calculator quite a bit this year. The way I do it is I start at -3 on the y-axis. The slope is your rise over your run. So you're going to rise 1, run 2. Rise 1, run 2. And keep doing that all the way, or you could go down left. Down 1, left 2. And that would be your line. Now, y equals 2 is a horizontal line. There's a phrase you'll hear me say. It's called hoi vernox. Hoi is a horizontal, zero slope, y equals. Horizontal y. So you just go to 2 on the y and you draw a horizontal line. If it was x equals, it would be a vertical line for x equals, which vertical lines have no slope. That's what the one in the middle is. All right, next page. Graphing more lines. So again, this is just function notation. There's a negative slope, so I usually put the negative on top. So I start at 5 on the y, 1, 2, 3, 4, 5. And I'm going to go down 3, right 2. Down 3, 1, 2, 3, right 2. Down 3, right 2. Down 3, right 2, and then draw your line. You want to draw it all the way across the grid that I've given you. This one, you have to solve for y. So if you solve for y, you get y equals -1/3 x minus 2. So again, you would start at -2, and you're going to go down 1, right 3, down 1, right 3, or up 1, left 3, up 1, left 3. These both have negative slopes. Okay, now simplifying. Answers must have positive exponents. Hopefully you remember your exponent rules, okay? Anything to a 0 power is 1. So this whole thing will go to 1, so we don't even really need to worry about it. 1 times anything is that self, 3xy. Negative exponents, if they are in a numerator, which this one is right now because there's no fraction on the bottom, they need to move to a denominator to become positive. So the way I do this is I make a fraction bar. A to the -2 is on top. I'm going to move it to the bottom and make it positive. This exponent is already positive, so I'm going to keep it where it's at, b to the 3rd. A to the 3rd is already positive also. You can keep it where it's at. Now just reduce. A squared and a cubed can reduce, so you'd be left with an a. So my final answer is a b cubed. I like things in alphabetical order, so try to write it like that. Let's do that again here. 4 to the -5th, 4 to the 6th over 4 squared. So again, this belongs down here. 4 to the 6th can stay on top, 4 to the 5th can go down, and 4 squared can go down. And anytime you're multiplying like bases, you add the exponents. Let me move that down here. So 4 to the 6th over 4 to the 7th. You will have 1 4 left on the bottom. What's on top is a 1, 1/4. Okay, Now, doing that here, I would not move this whole thing down just yet. I would actually distribute the power. Anything of power to power, you multiply those exponents. So this is really 2 to the negative 2, x to the negative 2. This one is 2 to the 3, y to the 3, and this is 4x. So now let's try to combine our like bases. So 2 to the negative 2 times 2 to the 3, you keep the base, add the exponents would be 1, so I'm not even going to write it there. X to the negative 2 and x to the 1, keep the base, add the exponents would be negative 1. What else do I have? Y to the 3rd, which stays there, and a 4. So let's see what that will become. So 2 times 4 would be an 8. Y to the 3rd would stay here, but that x to the negative 1 would just go on the bottom. And that's the answer. Let's do that again here. These are all multiplication. There's a power, so we multiply the power to the power. So a to the negative 3rd times a to the negative 2 is a to the positive 6. B squared to the negative 2 would be b to the negative 4th. This would be c to the negative 2. On the bottom, I would have a to the negative 1, b to the positive 2, c to the negative 3. Now, anything that's negative on top belongs on the bottom. Anything that's negative on the bottom belongs on top. So if I were to simplify this and keep what's positive where it's at, so this is a to the 6th. This goes up, a to the 1st. This b to the negative 4 goes down and becomes positive. This b squared stays down. This c to the negative 2 goes down. And this c to the negative 3 goes up, and it becomes positive. And then you simplify that, and you should end up with a to the 7th c over b to the 6th. This one can be tricky. Again, you're not using calculators, so what do? How do I know? I don't know what 8 times 3rd. Do I have to multiply it all out? No. These are all bases of 2. So you have 2 to the 4th. 8 is really 2 to the 3rd, right? But then you're raising it to a power of 3, which means you have to raise this to a power of 3, so that's really 2 to the 9th. Same with 16. 16 is really 2 to the 4th. It took me a second for a second. So 2 times 2, 2 times 2. But you're raising it to a negative 2 power, so it'd be 2 to the negative 8. 32 is really 2 to the 5th, but you're raising it to a negative 1, so on the bottom it'd be 2 to the negative 5. And then you do exactly what we're doing before. If it's a negative exponent, move it. If it's positive, keep it. So you'd have 2 to the 4th, 2 to the 9th. This 2 to the negative 5 would come up to positive. This 2 to the negative 8 would go on the bottom. And then you simplify. Let's see, these 8 and 9, you'll be left with 1, 2. Keep your base, add those exponents. So 4 plus 1 plus 5 is 2 to the 10, and you can leave it like that since you don't have a calculator. All right, last 3. So this 2 is going to every single one of these powers. This 3 is going to every single one of these powers, and then we're going to reduce. So 5 squared is 25. U squared to the 2nd is u to the 4th. V squared. The bottom 2 squared is 4. U squared, v to the 4th. Here we have negative 3 to the 3rd, which is negative 27. U to the 3rd, v to the 3rd. The bottom would be 2 to the 3rd, which is 8. U to the 6th, v to the 3rd. Now, when you are multiplying with fractions, you can crisscross cancel, or you can cross up and down. So like you can even get rid of those. V squared, v to the 4th, you can have a v squared left on the bottom. U squared, you have a u squared here. Here you would have a u to the 3rd, and you just keep reducing u squared and u to the 3rd. You would have a u on the bottom. And then you can even reduce the numbers if they can. I don't think they can. So I think you end up with negatives. Now this one, 3 to the negative 1 plus 2 to the negative 1 squared, you cannot distribute that power. This is not a multiplication sign. So you have to rewrite these two first. Whenever there's an addition, you have to rewrite them first. So 3 to the negative 1 would be 1/3. 2 to the negative 1, 1/2. Anything to a negative 1 is just the reciprocal. And now you're going to add them just like you would fractions. 1/3 and 1/2, well, they have a common denominator of 6. So that would be 2/6, which is 1/3, plus 3/6, which is 1/2. So that makes 5/6, but you are squaring that. So now you do that power at the end. So the final answer is 25/36. We're going to take that same idea to this one right here. You have a minus here, so you cannot just multiply these together. There's a minus separating them. So we're going to rewrite this as 1/a. This 3a to the negative 2 would actually be 3/a squared. And on the bottom, 2 to the negative 2 is really 1/2 squared, which is 1/4. Now, what you have here is a fraction within a fraction. So we are going to clean this up. And the easiest way to clean up a fraction within a fraction is find the common denominator from both the top and the bottom. So I see a 4 and an a squared would be the common denominator. So I multiply this by 4a squared, and I multiply this whole thing by 4a squared. Whatever you do to the top of a fraction, you can do to the bottom. So let's distribute that and see what happens. So 1/a times 4a squared would be 4a. 3/a squared times 4/a squared would just be 12. And on the bottom, 1/4 times 4/a squared would be a squared. And that's it. There's nothing to simplify. You could factor out a 4 here, but that'll be it. All right, I'm going to pause it right here. Hopefully you learned something from the first 2 pages, and then you can start up on the next.